Discovery alert. 2 new, rocky planets in the solar neighborhood. Illustration of 2 newly discovered, rocky, super-Earths, that could be ideal for follow-up atmospheric observations. Credit: NASA, JPL Caltech News, June 15, 2022. The Discovery, NASA's TESS mission, has found 2 rocky worlds orbiting the relatively bright, red dwarf star HD 260,655, only 33 light-years away. The new planets, HD 260,655b and HD 260,655c, are among the closest known rocky planets yet found outside our solar system that astronomers can observe crossing the faces of their stars. Key facts: using NASA's orbiting planet Hunter, the Transients Exoplanet Survey satellite TESS, scientists discovered sibling planets in Earth's size range that are prime candidates for atmospheric investigation. And the discovery comes at an ideal moment. The giant James Webb Space Telescope, soon to deliver its first science images, can examine the atmospheres of exoplanets, planets beyond our solar system, to search for water, carbon molecules and other components. Learning more about the atmospheres of rocky planets will help scientists understand the formation and development of worlds like our own. The latest discovery alert: 2 new, rocky planets in the solar neighborhood. Discovery alert: 30 exocomets orbit a familiar star. Details: both planets are super-Earths, terrestrial worlds like ours, only bigger. Planet B is about 1.2 times as big around as Earth, Planet C 1.5 times. In this case, however, neither world is likely to support life. The temperature on Planet B, nearest to the star, is estimated at 816 degrees Fahrenheit, 435 Celsius, Planet C 543 Fahrenheit, 284 Celsius, though actual temperature depends on the presence and nature of possible atmospheres. Still, the science team that discovered the planets says they are well worth further investigation. At 33 light-years, they are relatively close to us, and their star, though smaller than ours, is among the brightest in its class. These and other factors raise the likelihood that the Webb telescope, and perhaps even the Hubble Space Telescope, could capture data from the star's light shining through these planets' atmospheres. Such light can be spread into a spectrum, revealing the fingerprints of molecules within the atmosphere itself. Both planets rate in the top 10 candidates for atmospheric characterization among all terrestrial exoplanets so far discovered, the team says. That places them in the same category as one of the most famous planetary systems, the 7 roughly Earth-sized planets around a star called TRAPPIST-1. The TRAPPIST-1 worlds and several other rocky exoplanets are already on the list of observation targets for the Webb telescope. Fun facts: the jury is out on whether either newly discovered planet possesses an atmosphere, and if so, what it's made of. But the science team's analysis already has produced some intriguing clues. TESS finds exoplanets by watching for transits, the tiny drop in starlight when a planet passes in front of its star, which can reveal the planet's diameter. But the scientists also use data from ground-based telescopes to confirm the existence of the 2 new planets. These telescopes measured the wobble of the star, caused by the gravitational tugs from orbiting planets, which yields the planet's mass. Combine these measurements, and you can determine the density of the planets, in this case confirming they are rocky worlds. The measurements also suggest that if the planets do have atmospheres, they are not extended, hydrogen atmospheres. The discoverers, an international team of astronomers led by Rafael Luque of the Institute of Astrophysics of Andalusia, Spain, and also of the University of Chicago, used TESS data to make the discovery. The team's paper has been accepted for publication in the science journal, Astronomy and Astrophysics, with presentation of its results at the American Astronomical Society meeting in